For this video, we will be talking about section 3.2, which is functions. To start, as always, we have some vocabulary here. So our first vocab word, a function, is a relationship between input and output. In a function, there is exactly one output for each input. Second vocab word here, equations that are functions can be written in a form called function notation. Function notation is a way of writing an equation so that y equals f of x, meaning f of x is the same thing as y. So when you're used to seeing maybe y equals 2x plus 7, you could also rewrite that as f of x equals 2x plus 7. So this f of x right here is that function notation. The last vocab word we have here is the vertical line test. And this can be used to see if a graph represents a function. A relation is a function if it passes the vertical line test, meaning a vertical line intersects the graph no more than once. We will talk about that on this next section down here. So looking at 1 through 5, we are supposed to determine whether each relation is a function, and then we have to explain. So if you remember from the vocab word up there, actually, we're going to go ahead and make a note of this. There is exactly one output for each input, meaning, oops, let me get my pen back here, meaning x cannot repeat. So you can't have two of the same x values, because if that's the case, then you would have one input technically, because if they repeat, it'd be the same number twice, and they would have two different outputs, but this says there's only one output for each input. So going back down here to 1 through 5, number 1, we have these numbers right here for our x values. Now, when I'm looking at a mapping diagram, I'm looking at if any of them have two arrows coming out of them, because that would be a repeated x value. So I only see one arrow coming out of these. So that means that my relation would be -4, -1, -2, 3, 2, 3, 5, 6, all in parentheses. So therefore, we can say that this is a function. Each input has only one output. So that's what makes that a function, that none of the inputs repeat. So each of the inputs have one distinguished output. Number 2, this one, again, we're looking for if any of our x values repeat. And in this case, I see that 4 is there twice. So that means 4 maps to 7, and it also maps to 13. This cannot happen because, again, that vocab word for function says there's exactly one output for each input. So right now, 4 has two different outputs. So in this case, this would be not a function. And we would say because 4 has two outputs. Okay, moving on to number 3 here. Again, all I really look for when I look for these is if any of my x values repeat. So I see for my domain, which are all my x values, I have 2 2s. So again, this would be not a function. 2 has two outputs. Okay, for 4 and 5, now we have a graph. This is when we use the vertical line test. So if you remember, it's kind of at the top of my screen right now, but it says the vertical line intersects the graph no more than once. So if I drew a vertical line right here, I see that my graph only intersects once. If I drew a vertical line all the way over here, it doesn't intersect at all, which is fine. If I drew one here, it intersects just one time right here, and I could draw so many more. But as long as I can draw an infinite number of vertical lines and it passes all of them, then this is a function. So this one we would say it is a function. And we're literally going to say because it passed the vertical line test. That's that VLT right there. So again, your vertical line can only hit the graph one time for every line that you draw. Now on number 5, if I drew a vertical line right here, I see that it only hits once. So far, so good. If I drew a vertical line all the way over here, it doesn't hit it at all. That's also okay. But then if I draw this vertical line right here, we see that my graph intersects that vertical line in 2 places, right there and there. So this would actually not be a function. And we could say simply because it failed the vertical line test. So in this case, this would be an ordered pair of, let's just call it 2, 3, no, that would be 1.5 maybe. And then we have another one that's at 2, this would be 1, 2, 3, 4, maybe 4.5. So right there, we know that we have 2 2s and they each have different outputs. So that's what makes it not a function. And that's why we're able to use that vertical line test to make sure that none of the x values repeat. Now, going on down here to number 6, we have analyzing data. So 5 schools are competing in the long jump portion of a track meet. The distance of the players with the best jump on each team are as follows. Part A says make a table. So over here, we're going to draw just a little T chart. And teams is on top. And then best jump would be on the bottom. So team 1 had 20.6 feet. Team 2 had 21.5. 3 had 20.9. Team 4 had 19.4. And then team 5 had 20.2. So then part B says determine the domain and the range. So our domain is all of our x values, or the first set of data. So that would be our squiggly bracket 1, 2, 3, 4, and 5, separated with commas, closing with the squiggly bracket. Now, the nice thing was for our domain is when we listed all of that out, it was already in numerical order, but please remember our range also has to be in numerical order. So I'm going to put range here. And remember, this is all of our y values. So starting with the squiggly bracket, putting these in numerical order, 19.9 looks like it's the smallest number there. Sorry, 19.4 is what I meant to say. And then we have 20.2 would be after that. Then let's see, something else that you might want to do is maybe underline them as you write them down. Then it looks like it would be 20.6. And then we would have 20.9. And then we would end with 21.5. So again, remember, your domain and range have to be in numerical order. Now, the next thing is determine whether the relation is a function. Remember, for it to be a function, there can only be one output for each input, or the x values cannot repeat. So looking at our domain, we have 1, 2, 3, 4, 5. None of those numbers repeat. This would be a function. So then I'm just going to write function. And that is it for number 6. Okay. For the back of our notes here, we have find function values. They give us 2 different functions, f of x and h of x. You'll notice that there's 2 expressions that go with the respective. F of x is negative 2x plus 9, and then h of x is negative 3x squared plus 8x. I do want to point out really quick that we say f of x as f of x. That's what I'm saying when I say that out loud. And then this would be h of x. This is called function notation. So basically what we're doing here is a glorified substitution, input, output type of thing. If I plug in on number 7, if I plug in 4 for x, what do I get out for my answer? So the tricky part about this is just the way we write it all, the way we show our work, and then how we write our final answer, just keeping it in the function notation. So on number 7, again, like I said, this is a glorified version of them saying, hey, I want you to plug 4 in for x in the f of x function. So you do have to match the letters up. So we're using this function right here. So then I would have f of 4 equals, and I'm actually just going to piggyback off of this, and I'm going to use that first line there. So f of 4 equals -2. I'm plugging 4 in for x, and then plus 9. Remember, when you plug something in for a variable, a number in for a variable, you have to use parentheses here. Now, I am going to keep that f of 4 equals -2 times 4 would be -8, and then plus 9. My final answer here would be f of 4 equals -8 plus 9 would be 1. This would be my final answer. This is what I was trying to say about the whole function notation thing. This f of 4 equals 1. We have to have this as our final answer. You cannot leave off the f of 4. You cannot just tell me the answer is 1. This is basically you telling me that when I plugged in 4, I got 1 for my final answer. Think of it as like storytelling, if you will. Number 8, when they ask us for h of -2, that means I'm taking -2 and I'm plugging it in for x in the h of x function. Now you'll notice h has 2 x's here, so we're actually going to have to plug -2 in twice. So then we have h of -2 equals -3 times -2 squared, and then plus 8 times -2. And then from here we just simplify. So then I have h of -2. Again, this side is just you telling me that you're plugging -2 in for x. -3 I'm going to bring down. -2 squared is -2 times -2, which would become a positive 4 here. And then plus 8 times -2. We are following PEMDAS here, so we're parentheses, nothing inside of each of those parentheses. Exponents would come next. That's why I did the -2 squared. Now we have to multiply. So then h of -2 equals -3 times 4 is -12. And then a positive 8 times a -2 would be -16. Please, please, please remember, we do not put plus a negative. It is not plus -16. We're trying to clean it up as much as we possibly can. Last step here would be to actually combine the -12 and the -16. So then I have h of -2 equals, this would be -28. And then again, just trying to really, really emphasize the h of -2 has to be part of your answer. Remember, this is you telling me that you plugged in -2, you got -28 for your final answer. So input, output. Input was -2, output was -28. Looking at number 9, now they want us to find f of 6, but then after we find f of 6, aka plug 6 in for x, after I do that, they then want me to add 3 to my final answer. So we're actually going to do this in 2 steps. This is going to be my step 1. I'm just going to focus on finding f of 6. So when I do that, I have f of 6 equals -2 times 6 plus 9. Again, I'm just using the f function here. So then we have f of 6 equals -2 times 6 is -12, plus 9 would give me -3. Notice I did some mental math here. I didn't show as many steps as I did on 7 and 8. I'm totally okay with that. After that, now we have to focus on this plus 3. That's going to be my step 2. But at the end of this, we have to keep that whole function notation the same. So f of 6 plus 3. Again, remember, the left side is basically you telling me what you're doing, telling me a story. So you're telling me that I plugged 6 in for the f of x function, I got out a number, and then I'm going to add 3 to it. So then over here on the right side is me actually fulfilling that story. So f of 6, I got -3, then I have to add 3. Please understand that that plus 3 is the same on both sides. Because again, the left side is you telling me what you're doing, the right side is you actually doing whatever it is that we're supposed to be doing here. So then, please understand we're not solving an equation here, we're not subtracting 3 from both sides. This side never ever changes. F of 6 plus 3. That is what the original problem was. That should be in my final answer. Then, -3 plus 3 is 0. So again, this is you telling me that when I plugged in 6 and then I added 3, my final answer was a 0. And then moving on down, to 10, 11, and 12. 10 is very similar to number 9 that we just did. So we have the h of 5 function first. That's going to be our step 1. So h of 5 is going to be, and I don't have the functions on my video right now, but they should be on your notes. They should be at the top of your paper still. So then if I plug this in, I would have -3, 5 on the inside squared, and then plus 8 times 5. When I go to do this, I have h of 5 equals negative 3 times 5 squared. 5 squared is 25, times negative 3 would be negative 75, plus 8 times 5 is 40. So then I have h of 5 equals negative 75 plus 40 would be negative 35. That's my step 1. Then my step 2 is going to be this minus 7. But again, it's taking the entire thing. So then really now we have h of 5 minus 7. Again, the left side is you telling me what you're doing. You're going to take whatever you got for h of 5, which for us was negative 35, and then we're going to subtract 7 from that value. So h of 5 minus 7 equals, remember, the original problem should be in your original, or sorry, the original problem should be in your final answer. And then negative 35 minus 7 would be negative 42. That is our final answer. Okay, now on 11 and 12, they actually are asking us to evaluate twice. They want us to start by finding f of negative 3. So if I do that, I have f of negative 3 equals, plugging negative 3 in for x would be negative 2 times negative 3 plus 9. This answer, f of negative 3 equals negative 2 times negative 3 is positive 6, plus 9 would be 15. Now, this is going to be my step 2. I'm going to focus on now just finding h of negative 1. So then this would be negative 3 on the outside, negative 1 squared, and then plus 8 times negative 1. Okay, negative 1 squared would be a positive 1. Times negative 3 would be, oops, I forgot to write h of negative 1. This would be negative 3, and then 8 times negative 11. Now, for step 3, they actually want us to add those two values together. So at this point, this is when I'm going to write this entire final thing, whatever we get for h of negative 1. So then, again, the left side is you telling me what you're doing. The right side is you actually doing whatever it is. So f of negative 3, we got that value to be 15. They want us to add those two numbers together with h of negative 1 would be adding negative 11 here. Now, this does technically break our adding a negative here, but we are just showing our work here that this is technically a no-no for us, but we are showing what we're doing, so I'm fine with it here. If you wanted to just go straight to it being a minus sign, I would love that even more. But then my last step here, f of negative 3 plus h of negative 1, 15 minus 11, or plus a negative 11, would end up with a final answer of 4. And again, let me be crystal clear. This part of your answer has to be there. That is called function notation. We do have to show that. Remember, that's you telling me how you got your answer of 4, by plugging in negative 3 to f of x, by plugging negative 1 into h of x, and then adding those two numbers together. And then last but not least, we have number 12. So again, step 1 is going to be finding h of 4. So h of 4 would equal negative 3 times 4 squared plus 8 times 4. H of 4 equals negative 3 times, this would be 16, which would be negative 48, and then plus 32 would be negative 16. So I really skipped a lot of steps on that one, showing all of the work, which I'd be totally okay with, because technically speaking, you could type this entire thing into your calculator and it would spit out negative 16 at you, which is totally fine with me. And then after that, step 2 is going to be to find f of 15. So then this would be negative 2, and then in parentheses, plugging in 15 plus 9. Negative 2 times 15 would be 30, plus 9 would give us f of 15 equals negative 21. And then last step here, they want us to now subtract the two numbers together. So remember, this is now going to entail this whole thing. So we have h of 4 minus f of 15. Remember, the left side is just you telling me what you're going to do. The right side is you actually doing that. So then h of 4, we got that number to be negative 16. And then it's minus, from this minus sign right here, f of 15 was negative 21. So be very, very careful on this one. You do have to make sure you pay attention. This minus sign right here came from them telling us that that's what they wanted us to do with the two numbers. This negative came from it being a negative 21. Now, two negatives in a row do actually become a positive here. So then really we have h of 4 minus h of 15. So basically you telling me that when I plugged in 4 for h of x, when I plugged in 15 for f of x, and then I subtracted the two numbers, I get a final answer of negative 16 plus 21 is 5. Okay, and then moving right along here, we now have number 13. Dana works at the movie theater after school. The function they give us, g of x equals 925x, represents the amount of money he makes before taxes for each hour he works. Evaluate, which is what we were just doing up above, but then it also has us interpret the function for each value, meaning write a sentence. So part A says g of 8, meaning we would be plugging 8 in for x, so 925 times 8. When you evaluate that, we get g of 8, again, keeping that function notation, equals 74. That is our first answer. Now, that was just the evaluate part, but again, we have to interpret the function, meaning write a sentence. So we are talking about the amount of money he makes for each hour he works. So if you think about it, you have to know how many hours you work before you know how much you get paid. So you have to think about which one's your independent and your dependent variable, aka which one's your x and your y. So in this case, your input or your independent variable is 8. So that would mean after working 8 hours, Dana earns $74, and that would be our sentence for part A. Now doing the exact same thing for part B, so g of 27.5, meaning we're going to plug 27.5 in, so 925 times 27.5. This would give us g of 27.5 equals, this would be 254, 375. Now, that is kind of a weird number to get when we're talking about money. So when we go to actually write our final sentence here, we would say, after working 27.5 hours, which is totally fine. 0.5 would just mean 30 minutes. So after working 27.5 hours, Dana earns 254 point, we can't put 375 because that's not how you write money. So we'd have to actually pay attention to 0.375. We have to round to the nearest hundredth here. So then the 5 is going to tell the 7 to round up to 8. So then this would be 0.38 for our final answer. Please make sure, just a rule of thumb, you are labeling with hours and a dollar sign. Hours and a dollar sign. In these sentences, you do have to have two labels. Make sure you address both of them. But that is it for these notes.